In the opening video of coordinate geometry, I had asked the question as to how computers and your phones calculate distances in a video game. How do they calculate the position and the movement of a ball? Let's see if we can use our knowledge of coordinate geometry to calculate the distance between points. Let's begin with these four very simple points and ask the question, how far are they from the origin? Well, if we consider this green point, it is 1, 2, 3, 4, 5, 6 units, and we can do this simply by counting the number of units it is from the origin. The blue point is 3 units, the red point is 7 units, and the green point is 8 units. One question that might have come to your mind is, shouldn't this actually be minus 7? Shouldn't this also be minus 8? Well, let's look at it this way. Here remember, we are talking about distance and we are not talking about the coordinates. So when we say it has a distance of minus 7, what really do we mean? Because minus 7 could be 7 units to the left of the origin along the x-axis. Minus 7 could also mean 7 units south along the y-axis. So which is it? Is it 7 units along the x-axis or 7 units along the y-axis? The fact is, we really can't tell, and therefore using signs while expressing distance is of no use to us. Let's take less simple cases. These 2 points do not sit on the axes, and we ask the question, how far are they from the origin? Now we find there's no simple counting method here that we can use in order to find this distance. So we take the help of another mathematical principle, the Pythagoras theorem. Now different people pronounce it differently. You can say Pythagoras, Pythagoras, but whatever way you pronounce it, it is a formula in mathematics that deals with right angle triangles, any triangle that has a 90-degree angle in it. In such a triangle, if we label the 2 perpendicular sides as A and B, the third non-perpendicular longest side is called the hypotenuse and given the symbol H. Pythagoras found that the length of the hypotenuse squared equals the length of the sides. Length of the hypotenuse squared equals the length of one side squared plus the length of the other side squared. So how can we use this to find our distance from the origin? Well, if we think of it as a right angle triangle, if you remember, our y-axis and our x-axis are perpendicular in a Cartesian plane. So then we can simply consider these to be the sides A and sides B, and this to be the hypotenuse. If we know the length of A and know the length of B, we can use this formula to calculate the length of H. Now, does it matter if I consider this side to be A and the other side to be B? It doesn't really, because if you take a look at our formula, it is A square plus B square. We can reverse the order and call it B square plus A square. It will not change the outcome. So it does not really matter which one you consider to be A and which one you consider to be B. So let's take this a step further. H square equals, now what is the length of A? This side A is 1, 2, 3, 4 units along the y-axis. So we will say 4 square plus B is 1, 2, 3 units along the x-axis. So H square equals 4 square plus 3 square. So H square equals 16. 4 square is 16 and 3 square is 9. Therefore, H square equals 25, and therefore H is the square root of 25. In other words, H is 5 units. Now, what if I consider the red dot? If we notice, it is also 4 units along the y-axis and -3 along the x. Should we just disregard it, or is there some mathematical logic I can use? So we're going to follow exactly the same procedure. However, what we're going to do here is, instead of using 3 square, I'm going to erase this and I'm going to put in its place, I'm going to add -3 squared. Now, what is -3 squared? It is -3 times -3. And -3 times -3 gives us 9. So it doesn't really change anything. It doesn't really change anything. I can even take this distance as -3 in this formula and still actually get the correct answer, which is 5 units. And magically for me, my answer does not contain any sign.